In this episode of Cube FM, I got a chance to speak to William Morgan, who's the CEO of Buoyant and core contributor to Linkerd, about the challenges and trade offs of Kubernetes topology aware routing, or TAR. Designed to reduce cross zone traffic costs, TAR can unintentionally undermine system reliability by limiting interzone communication, leaving services vulnerable to localized failures. We also discuss how L7 load balancing offers more granular control compared to L3, L4 approaches, and why developers should prioritize business logic over navigating Kubernetes complexities. William shares insights on the evolving adoption of Kubernetes, highlighting a shift toward more principled networking policies and the persistent pain points of managing them. Additionally, we touch on how AI tools can assist in generating Kubernetes configurations and simplifying workloads. As the Kubernetes ecosystem matures, we explore how the future of networking aims to balance cost, reliability, and simplicity, ensuring that developers can build resilient applications without unnecessary overhead. This episode is sponsored by LearnK8s. LearnK8s provides Kubernetes training online and in person to groups and individuals all over the world. Courses are instructor-led and 60% practical and 40% theoretical. Last but not least, students have access to the course materials forever. For more information, check out learnk8s.io. Now, let's get into the episode with William. All right, William, there are a lot of tools in the Kubernetes world, but which three emerging tools are you keeping an eye on?
Oh, well, I don't know if it counts as emerging, but I'm definitely keeping an eye on Linkerd, which is my favorite tool. I've given my whole life to this tool, so I hope it does well. Um, and then I'm going to be really, I think, pragmatic about it and say, Helm and probably a 50-50 split between Argo and Flux. And that's purely based on the tools that I see used with Linkerd every day in production. So there you go.
Okay, but not taking a side on Argo or Flux. GitOps reuse even keel.
Again, I'm trying purely to be pragmatic. I don't really care. I'm sure one is vastly better than the other, but I don't know which one.
Okay, fair enough. All right. Well, we did have a previous conversation, about how you got into cloud native. What were you before cloud native and things of that nature. Being in a position of leadership, though, if there's one piece of advice that you could give to other open source, CEOs that are in this ecosystem, what would it be?
Wow, other open source CEOs. Yeah, run away. Don't don't come over here. No, I think the advice and I'm going to be talking a lot about this at KubeCon. I'm on two panels basically about this exact same thing, and it's exact same topic at Salt Lake City. Um, I think my advice would be have a clear model for monetization and be really upfront about that with the community, even though you're going to get pushback about it. I think you have to be out there and you have to say, this is how this project's going to get funded. And if that's if it's an ethical problem for you to never pay, to pay money for software, then maybe this is not the project for you. But I think you have to make that really explicit to people in this ecosystem. Otherwise, all sorts of other dynamics come into play. So yeah, that's my advice.
Sound advice? Now, for the purpose of today's interview, we came across an article that you wrote called The Trouble with Topology Aware Routing, Sacrificing Reliability in the Name of Cost Savings. So the following questions, we're going to be focused on that. But just to get started, could you walk us through a quick explanation of what topology aware routing is in the context of Kubernetes and why it's being widely discussed?
Yeah, yeah. So let's look at the situation. So this is a tool that was developed to solve a specific problem, and the problem is I am running a multi-zone cluster. Okay, so I'm using a cloud provider. The cloud providers have kind of two tiers. Basically, they have what region you're in, and they have what zone you're in. And different cloud providers have very different kind of semantics for what those things mean. But generally speaking, region is bigger than zone, and a region failure is rarer than a zone failure. So it's part of their as part of the cloud provider's kind of like failure domains as a providing team. So one common model in that world, and this is like a best practice in the docs from some of the cloud providers, whether you choose to believe it or not, is to deploy a multi-zone cluster, which means I've got a single Kubernetes cluster, but the nodes are going to be spread across zones. Typically, it's 3. So AWS is kind of the canonical example here, and I think it's in the AWS docs. If you're making a Kubernetes cluster, you deploy the nodes across all 3 zones. And then if one of the zones goes down, your cluster still functions because 2 of them are still remaining. And Kubernetes is a distributed system, and like you've got this nice reliability property. So that sounds nice. Now the problem is, or at least from the user's perspective, is that the cloud provider will charge for the traffic that crosses zone boundaries. So that means if you have little traffic, it's not really a problem. But if you have a lot of traffic, that number could actually be quite large over time. So that number, you could end up paying millions of dollars every year just for cross zone traffic. So obviously, like, that's terrible, right? And the reason that happens is because Kubernetes is doing the right thing, right? It's saying, I'm going to load balance and I'm going to spread the traffic and the load as best I can across everything. Like, that's what you want for reliability. But then you get charged for traffic that goes across zones. Again, if you have a tiny amount of traffic, it's $4. Who cares? If you have a huge amount of traffic, you're in millions of dollars. Okay, big problem. So that's the situation. Does that make sense so far?
Yeah, no, that's great. In terms
Okay.
of the specific problems, though, that the topology-aware routing is trying to solve regarding cost and cross-zone traffic, could you give some specific examples of real-world cases where you've seen this?
Yeah, yeah. So on top of that problem, we now introduce topology-aware routing, which is a feature built into Kubernetes that you can enable that says, hey, I'm actually going to prevent traffic from crossing zone boundaries. Okay. So great, problem solved, right? Like, we no longer have cross zone traffic, except, obviously we do want cross zone traffic in certain situations, right? If something starts failing, well, we want the traffic, to recover across zones. Um, and so topology-aware routing has a whole set of rules under which it'll disable itself. So if it detects, for example, that and I'm getting to a concrete example, if it detects that all of the instances of a service in one zone suddenly, go down, well, then it'll turn itself off and it'll allow all traffic to happen between zones. And so you kind of you get back to the reliability, um, you know, uh, a guarantee that you want. So one concrete example, I think, is for a database. Typically, a database will be distributed. If you have a distributed database, you'll have a different kind of like set of database instances per zone, and that's the thing that if your database goes down in one zone, well, suddenly you're in a difficult situation, right? None of your services can require that database can answer requests. So in that situation, you then want the traffic to be handled by the other 2 zones. So topology-aware routing is basically a nice switch you can turn on that the promise is that, okay, while things are normal, you're not going to have that cross zone cost. So great, your cloud spend goes down. And then if things get busted, then like we'll disable ourselves and traffic will resume to or traffic between zones will resume, and you'll have a stable cluster again, even though your zone is down or your database is down in one zone. So it sounds great, right? Like, we solved the problem.
Sounds great. Regarding the cost, like the FinOps element of this, it's a topic that's been addressed, since that we could probably say the beginning of Kubernetes, as well as we're talking about cloud spend in general. This year, seeing IBM acquiring a company like KubeCost, how does this figure into the FinOps framework, the FinOps landscape, compared to some of the other practices being done out there to monitor, reduce, optimize?
Yeah, I mean, this is an interesting one in that it's kind of an avoidable cost, and it's even an arguable cost, because you could say, you know what, why are we doing multi-zone clusters in the first place? Like, does that really make sense? What a zone means in AWS is very different from what it means in Google, what it means in Azure. So a lot of this is very cloud provider specific too. For example, in Azure, Azure actually doesn't charge you for cross-zone traffic. So, like, maybe you don't care about this at all. Although there is a little asterisk in the pricing table that says at some point we will charge you and we're going to give you 3 months of notice. So, like, maybe that's scary for you. In Google, empirically, what we've heard from our customers is the zone, the network is so fast between zones that actually um, you end up in a worse situation if you're using Linkerd, um, than in AWS because Linkerd does uh, latency aware load balancing. So in AWS, where there's a high network cost in between zones, you can take stock Linkerd, throw it in there, and it'll start reducing the cross zone traffic just because it's slower. But in Google, that doesn't work. So it's a more nuanced. I guess my answer to that question is this is a more nuanced and maybe a more arguable cost. You have to have compute. You have to have you have to have ingress traffic. You have to have egress traffic. Um, Cross zone traffic, you really need it. Maybe you architect your cluster differently, but do one cluster per zone. You, I think the world of Kubernetes is kind of evolving, and in the what I saw in the earlier days was kind of a preference towards a larger cluster. Let's talk about multi-tenancy. Let's talk about one big cluster that's going to be our powerhouse cluster, and we're going to make it multi-zone, and we're going to make it like undefeated, right? And now there's kind of been a shift towards, well, let's have lots of clusters and let's have this kind of like federation of clusters. So that's a very long answer to a very short question, which is basically it's complicated.
And how does topology aware routing specifically impact the ability to manage zone level failures? I mean, could you explain some of the trade-offs it introduces in this regard?
Yeah, so I wrote this blog post not because I thought topology aware routing was like crappy or poorly designed. It's actually very well designed, and it uses all of the kind of Kubernetes primitives. But from the and I'll say Linkerd supports it. So if you enable that feature, and you're running Linkerd, then Linkerd will respect its rules. And the way that topology aware routing works basically is it says, I'm going to take all of these endpoints and I'm going to kind of lay down the layer 4 networking rules. And I'm going to say, if you are in zone A, you're not even going to know about an endpoint in zone B. And if you're in zone B, you're not going to know about an endpoint in zone A. And we're kind of going to restrict things at layer 4. And Linkerd will respect that, right? And so that's all well and good, but we kind of had this shift in Linkerd over the past year or two where we started, and this is going to sound very obvious in retrospect, but we started really paying attention to what our customers were like. Obviously, we should have been doing this the whole time, right? But a year or two ago, we were like, okay, let's make a concerted effort to really understand what are the problems that people are having. And what we found was that we had a lot of customers who were in the multi-zone case with lots of traffic, and they were not actually able to effectively use topology aware routing. And there were kind of two reasons for that. One was it was hard to get it working consistently. It would disable itself, under a whole set of conditions. It didn't compose well with auto scaling with like HPA, didn't compose well with some other features. It was kind of finicky, right? In order to have that reliability guarantee where they were like, hey, if something's going weird, we're going to turn ourselves off because it's better to be reliable than to be cheap. um, uh, they basically stopped using it, but they still had that problem. And then they also, we had other customers who were like, it didn't save us there were a lot of conditions under which our apps were failing. And we had topology aware routing, but topology aware routing didn't turn itself off. And so when we started digging into that, what we realized, and, obviously that's like a huge problem for some of these customers. What we started realizing was because topology aware routing is built on top of layer 4 networking, right? Which is fine. That's all it has access to in the Kubernetes world. There were lots of situations that it actually couldn't handle because handling them properly required understanding the protocol, understanding HTTP success rates, understanding request latencies, right? And so like naturally that caught our interest because that's right where Linkerd is, right? That's exactly our bread and butter. And so when we looked into it, we found is some interesting behaviors and kind of what I have to take a step back to explain something, to really understand this. I think you have to understand this model of in-band health checking versus out-of-band health checking. So you ready for a little digression?
Hit me with it.
Okay. So uh, a workload's running in Kubernetes. We want to health check it, right? And we want to know, is this thing healthy? Kubernetes does what's called out-of-band health checking, which means, application traffic is happening on port 1234. The health check is happening on port 4321. And that health check is, Kubernetes is running these probes and it's saying, hey, are you healthy? Are you healthy? And the app is saying, yes, 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 yes. Now, if you look at the actual code, typically there's like the handler function for the health check, and then there's a handler function for the actual application code, right? And the handler function for the health check is, typically it's like return yes or return okay, right? And then the handler code for the application call is like, whatever complicated business logic we have. So you kind of have this decoupling, right? And the consequence of that is that if something starts going wrong with the application, it's not always reflected in the health check, right? So that's this out of band, it's called out of band because like the band is the actual application traffic. These out of band health checks could only capture a certain class of failure. So for example, if our database, in the database example, let's say our database was just like taking forever to respond. Okay, so it's not failing. It's just like it's taking, it should take 300 milliseconds instead of taking 30 seconds. Okay, and our application starts timing out and then starts returning, let's say it's an HTTP application, so it starts returning 500s. The health checks are going to say, I'm fine. Like I, as an application, am fine. But the traffic, the user-facing impact is like this thing's dead, right? All I'm getting is 500s. So that's the kind of situation that topology-aware routing cannot capture, not because it sucks, but because it can only make use of these in-band or out-of-band health checks. Now, when you move to the service mesh layer, and this is true of Linkerd, it's true of any service mesh, well, suddenly you have access to the entire application traffic. You can parse it. You can say this is a 500 versus a 200, right? Or this is a gRPC error versus a gRPC success. So now you can start doing what's called in-band health checks, which you can say, hey, this service is running, it's responding okay to its like Kubernetes probes, but every time I call it, it's returning a 500. The service actually is not healthy. Does that make sense?
Yeah.
Okay.
One thing to double check here, if we're thinking about dependencies, how does Kubernetes implementation of topology-aware routing impact critical dependencies across different zones? And what alternatives exist for maintaining reliability in such setups?
Yeah, right. So topology-aware routing itself doesn't really know about dependencies because dependencies is kind of like an emergent kind of property of who's communicating to whom. So topology-aware routing, you enable it for a service or for all of your services, but it doesn't really know, okay, this service is a dependency of this one, is a dependency of that one. In fact, Kubernetes itself doesn't really know that because in order to know that, you have to know what the call graph is. And, you can map that out by tracing the TCP connections, I guess, but there's no reason for Kubernetes to really do that. So typically in the Kubernetes world, and when I say Kubernetes, I'm including topology-aware routing. You just defer that to some other tool out there. You defer that to the CNI or you defer to the service mesh. So topology-aware routing doesn't really know about dependencies. It just knows, hey, if this service is healthy and it's got enough endpoints in each zone, then I'm going to prevent any connections, any TCP connections from crossing the zones. And if something goes wrong, then I'm going to like allow all TCP connections. So the reason we got into that, and that sparked our interest was Linkerd is in a position where it actually does know about those types of failures. It can actually say, hey, this service is returning 500s. Let's treat it as a failing service and let's, figure out what we can do. So we introduced a new feature called Hazel, which is, great. Maybe great name, which is high availability zonal load balancing. And what we're doing here is we're trying to solve the same problem that topology-aware routing is solving, but we want to do it in a way where we have full access to the traffic semantics between the different components. So that means not only do we understand the success rates, and errors, and we can capture the 500 return code case that I just gave an example of, the topology aware routing camps, but we can actually be even more nuanced, and we can say how much load is happening to this service in this zone, and is that load exceeding some threshold where we might want to broaden the set of endpoints that we're sending traffic to. So we ended up building this because we had access to all the layer 7 kind of semantics of traffic, and we know how many requests your application is handling. We know if there's is it queuing up? Are there it's got 30 requests outstanding? That's a sign that the service is overloaded. Maybe we need to add more endpoints and actually start sending traffic across zones. Oh no, if now things are going back down, okay, well now we can reduce the number of endpoints. So we end up with this very elegant system that can not only send traffic across. So, okay, when things are fine, right? When the system's at a steady state, we don't send any traffic across zones, right? Cost goes down. As things start getting under pressure, so not just failing, but as they start getting under pressure, then we start adding traffic across zones to reduce that pressure. And then when things return to normal, we shrink the set of endpoints back to the same zone. So with Hazel, you're able to get the best of both worlds. Not only do you have the cost savings benefit of not sending traffic across zones when things are fine and the system's in a healthy state, but as soon as the system starts getting overloaded, whether that's from traffic, an increase of traffic, or whether it's from a component failing or something else, well, then we can actually start sending traffic across zones to get you your reliability. Remember, I said earlier, being reliable is more important than being cheap. Being cheap is important, right? But sorry, I'll say being cost effective is important, but being reliable is typically your first kind of promise as a platform. So we end up with this really nice solution. Of course, you have to install a service mesh to use it. So, it's the trade-off there.
With that in mind, I mean, we're close to Black Friday, Cyber Monday, days where we're often talking about traffic, we're talking about reliability, we're talking about scalability, provisioning, load balancing. All those things are going to come into play. Specifically on the topic of L7 versus L3, L4 load balancing, in the article you mentioned layer 7 balancing as an alternative approach. What would be required to make this a viable alternative to topology aware routing?
Well, I think it's a superior alternative to topology aware routing already. Are you talking about L7 balancing, or are you talking about something like Hazel?
L7 balancing.
Yeah, so L7 load balancing simply means we're deciding where to send the requests based on kind of L7 properties. And L7, for those of you who are not immersed in the network space, basically means understanding the protocol. And there's a long and boring and complicated history for why we arrived at L7. But it means understanding HTTP, right? Kubernetes does not understand the protocol. It says, I'm going to make TCP connections and that's it. Topology aware routing, by virtue of being a Kubernetes subsystem, does not understand the protocol. In order to understand the protocol, effectively, you have to run a service mesh. So I would say that in order for L7 load balancing to be an alternative to topology aware routing, not only do you have to, kind of be able to balance requests, but you also need to know which services are in which zone, which endpoints are in which zone, and you need to know what are the characteristics or what are the situations under which I want to send traffic across zones. Let's say normally I don't want to. Under what situations do I want to? And that's effectively what we did. By the way, that's a solution that we built with Hazel. Is we put in enough logic in there where we could say, hey, L7 load balance, Linkerd's load balancer, instead of just balancing across all endpoints, just balance across the same endpoints in the zone. Unless you detect, something weird is going on, then start adding more endpoints across the zones. You can put in arbitrary costs per zone. You could imagine making this very, very intricate. We tried to compress it down to the simplest, user-facing kind of surface area. I think we can make it even simpler. As we roll this out into production and we see people use it, it's ways to make it even simpler. But yeah, that's basically what you would need to do to make L7 load balancing capable of doing topology aware routing or superseding topology aware routing.
Since you mentioned the end users, the people that will be working with this, we're thinking about developer versus operator perspectives. What do you think could be misunderstandings that developers or operators might have when deploying topology aware routing in cloud environments?
Yeah, so I have a very kind of strong opinion here, which is there's a developer side and there's the operator side, and that already makes me sound like a fuddy duddy, but maybe operator is not quite the right word. There's a platform owner side, and then there's the developer side, and I think that's kind of the model that we see as being successful in organizations that use Kubernetes effectively. So we've got our team that is owning the platform, and our responsibility is to build this internal platform for the developers. And then you've got the developers whose job is to write the business logic that powers, the application that powers the company, right? And so in that world, I argue pretty vehemently that the developers shouldn't know about topology or routing. They shouldn't know really about Kubernetes. They shouldn't be writing YAML or thinking about that stuff. I think that's the job of the platform. So, and I think if you're going to do this effectively, your contract with the developers as a platform owner is, hey, developer, you write the code, you press this button, and like it's going to run on the platform, and we're gonna promise you that it's going to be reliable, that it's going to be secure, and it's going to be observable. We're not going to be like on call for your service. You're not throwing it over the wall. You need to own, your own production setting, but we will provide the platform that will accomplish these goals. And you as a developer just focus on building a business logic and making sure that it is operable at scale.
To take this a little bit further, just because it's something that came up in a lot of conversations that we had when we interviewed 30, CNCF ambassadors about the next 10 years of Kubernetes, things up until now, and the least favorite feature when we asked people about their least favorite Kubernetes features, network policy management and things around networking came up a lot. Are you surprised by that? What would need to happen for that not to be the case? What are the things that you're seeing, both in terms of, the technical folks that are, contributing to projects such as Linkerd, as well as the end users in terms of the challenges that they're facing, the questions that you find yourself as, answering a lot. What world do we need to build for networking to become simpler?
Yeah, gosh, that's it's a great set of questions. My my instinct is that what happens when you start talking about, well, okay, so everything about Kubernetes is beautiful and pure, and we're talking about you know services and deployments and like objects that kind of make sense to developers as well as to operators or to platform owners. And even individual machines, we've kind of abstracted away. Yes, we've got nodes, but really what Kubernetes is doing is it's abstracting away the set of like machines into just like a pool, right? And like when you're using Kubernetes, you're not worrying about individual machines anymore. You're just saying, hey, I've got this service, and I've got this one, and like deploy them and you figure it out. But with the network, you don't quite get that. As soon as we start talking about network policies, we immediately see the underlying abstraction kind of melt away. And we're like, okay, pretty soon we're talking about IP addresses, and we're talking about, IP tables, and we're talking about, some other stuff. And I think kind of my hope for Linkerd, and I think that especially gets true when you move into the world of multi-cluster. You're like, okay, I've got these two clusters, well, I've got 200 clusters. And suddenly you have to figure out how is a pod in one cluster going to communicate with a pod in another one. And Kubernetes doesn't really give you a lot of primitives for doing that. I mean, it basically gives you nothing, right? So that's, you might, and not to sound too self-serving, but that's kind of what I hope the service mesh could be, is like, that is a layer of abstraction over the network in the same way that Kubernetes is kind of the layer of abstraction over the pool of hardware. And it's not quite as neat of a story as we'd like it to be. Obviously there's a lot of interplay between something like Linkerd and Kubernetes. Since you start talking about multi-cluster, this is just top of mind because we're busy adding new multi-cluster features to Linkerd right now. I think we've been we've been iterating on the name, and I think we ended up on federated services, where we're trying to explicitly capture, hey, I have a service and I want this same service deployed across 100 different clusters. But I don't want to have to manage it as 100 different individual objects. I don't want to have to interface with it from the kind of like the caller perspective. If I'm service A calling service B, I just want to talk to service B. I don't want to have to think about or know about the fact that it's actually replicated across 100 different clusters. What features can we build in Linkerd to, to ease that? Well, okay, we're working on something called federated services. Should be out in Linkerd 2.17, which is going out next month. Should be, that's exciting. But I think that's an example of the kinds of abstractions that we can start putting on top of the network. That the service mesh can provide on top of the network. Hopefully eases some of that, because at the end of the day, you don't really care. There's some wires somewhere, you assume. It's like you draw, network has to take a TCP packet from here to there. None of that is really that interesting from the platform perspective, with, no offense to the many network engineers who have spent their whole careers like making that boring. We're at the point where I think we want that to be boring, right? And we want to be able to talk about, instead of TCP packets and IP addresses, we want to talk about service A talking to service B, and like not have to worry about the implementation details.
And looking towards a future that, as you say, could hopefully be boring, do you think that topology-aware routing will become a standard part of Kubernetes networking or remain niche due to its reliability concerns?
Oh, I think topology-aware routing is going to be like a standard offering just because it's already in Kubernetes. And there's situations where you just want to turn it on and everything's fine. I think when you are outside of there's a limited set of situations where topology-aware routing can be really, really effective, and just use it. There's no reason not to. As soon as you go outside of those situations, you need more nuance, you need more control, you need to be able to handle different types of failure. Then you kind of have to use a service mesh for all the reasons that that we've discussed. You have to elevate that logic to L7. And so as much as I love talking about Linkerd, I think ultimately my advice to anyone is to be very pragmatic about these decisions. And if you're in a situation where there's a built-in Kubernetes capability that solves your problem, then use that. There's no reason to overcomplicate things. Just be aware of what the limitations are, and be aware of the situations where you want to, where you need to do something.
Given your experience, what advice would you offer teams weighing the cost savings of topology-aware routing against potential reliability risks?
I would say if you were in a situation where the cost of cross-zone traffic is like a significant number, the CFO or the finance team is coming knocking on your door and being like, hey, this is too expensive, I would seriously look at Hazel, the Linkerd feature. I would seriously look at topology-aware routing. I'd read through the blog post that I wrote, because I try to lay it all out and understand which situation are you in, because that cost is avoidable. You don't have to just give up and pay that. You can fix that. You just have to be very clear on what the reliability implications are, and how those apply to your specific situation.
As we get towards the end, William, what's
This is
one
the
thing
opposite of
people
my North Lacy Park. Normally I'm like, this is silver bullet. It's going to solve all your problems. Now I'm trying to be really, I'm trying to be low opinion here. Of course, my thing is the best. but you should evaluate all the options, and I'm confident that you will end up agreeing with me.
I always tell people, the less you sell, the more you will, and you're inviting further conversations, and that you're open to debate. And I think that's very healthy and a solid approach. In terms of, you're very active in this ecosystem. A lot of times we get to know people because of an open source project or a company that they're associated with. But what are things that people don't know about William, the person, that you would like them to know?
Oh boy, that I want them to know. Yeah, gosh, I've got horrible dark secrets galore. So there's a lot that I don't want you to know. I think one thing that's been particularly interesting to me with the resurgence of AI, and kind of everyone getting super excited about AI, is that's actually where I started my career. I went to school for natural language processing. My first couple of jobs out of school, out of grad school even, were all focused on, how do we make computers better at handling human speech, human text? And I got kind of annoyed with that field because I was like, it's too hard to make something that's a product. I was like, this stuff is never going to work, basically. And I moved to infrastructure where it was much easier to solve immediate and concrete problems. And so now it's really funny, it's like 20 years later, you're like, oh my gosh, like this stuff actually could work. You just needed 20 years of like serious research, to get back to it. So, um, yeah, I don't know. I don't know if there's not really
No,
a
that's
moral
interesting just
there.
because, we saw in the last KubeCon in Paris, a lot of conversations around AI. Some people might debate as to how concrete those conversations were, how realistic or tied to, real life situations. Where do you see this going? Because, if we're thinking about the stakeholders thing, right? We're talking about platform owners versus developers earlier. Your average Kubernetes, user, to what extent is AI impacting the work that they're doing right now? What do you expect there to be in the coming 6 months to a year?
Yeah, so I think there's a little bit of tension there in that, at least from my perspective, everything you're trying to do when you're building a platform, and certainly when you're building Linkerd, you're trying to make things as predictable as possible. You're trying to make things as cheap as possible. You're trying to make things as efficient as possible. Trying to make things as understandable as possible, right? Because the operator, my mental model of like the poor, bastard who has to like run Linkerd, at the end of the day, it's like they're going to be waking up at 3 a.m. and there's like alarm bells ringing in that they have to like somehow understand what's going on, right? So we have to make Linkerd so simple and so easy to understand that even in that situation where you're like bleary eyed and like this red light's flashing, oh, and drool is like coming out of your mouth, you can still, understand what's happening and fix the problem. And that's like a really, that's a pretty high bar to reach in this super complicated ecosystem. On the other hand, you know, um, and AI is kind of the opposite of that, right? It's like, how does it work? Well, it's a giant neural network and like it does some stuff and what's the output going to be? Well, let's try it and see. Like, but on the other hand, I do see, I see developers getting a huge amount of utility out of code generation, right? And I think that's probably the lowest hanging fruit for kind of the platform owner. It's like, hey, we've got a lot of YAML to write. We could kind of like generate a lot of that through AI. Now, is that a great solution? No, I don't think so. Because I think if you're in that world, it's kind of an expression of the fact that like you have these higher order abstractions that you're trying to accomplish. And the only tool you have for them right now in Kubernetes is like writing CRDs and YAML. So like, yes, we could use AI to like generate this stuff. Okay, great. That solves the generation problem, but you still end up with like 1,000 CRDs and like you have to understand them. Right. So I think that kind of speaks to there is some higher order abstraction you're trying to accomplish. And that's, I don't know if AI is going to be useful. But in that situation, that's a really exciting area for me because I'm like, I'm watching our customers build these giant platforms and struggle with like some really significant challenges when you have 200 clusters and, they're all talking to each other and the developers are trying to do this and security team is trying to do that. And everything ends up being YAML at the end of the day. You're like, okay, there's like something missing there. So that's a really exciting area for me. In terms of AI though, like I think that fundamental mismatch between predictability and expressiveness is what makes it hard to imagine how useful it really could be in a very direct way. So maybe I'm just lacking imagination. I'm sure I'll hear lots of great ideas at KubeCon, SLC.
Yeah. I'm sure there will be plenty of conversations around it, which is why I asked. I know that I asked about this previously about, the network policy management really stood out in the conversations we had when people were asked about what their least favorite Kubernetes feature was. In this regard, what's the thing that you see people getting wrong most frequently when it comes to networking on Kubernetes?
When it comes to networking as a whole, I don't know if I see people getting a specific thing wrong that's really networking specific. I think what the pattern that I see that happens, over and over again, and it's not like a failing. It's just a pattern that I noticed, is that I feel like Kubernetes adoption is going through a transformation now. And, the Kubernetes has been around for 10 years. Linkerd has been around for like 9.5 years. So we've kind of seen this from the beginning. Those in the early days, people were deploying Kubernetes kind of piecemeal. There'd be one cluster from one team over here, another cluster from another team over here, third cluster over there. And now people are coming back and they're taking another look and they're saying, hey, let's be really principled about this. Kubernetes is here to stay. It's not going to disappear. It's still growing. The ecosystem is still growing. Linkerd is still here. Linkerd is still growing. Like, let's build a platform and let's do it right this time. And so they're kind of taking a different approach and redoing a lot of what they did in the past. So is that a failure? No, I'd argue that's like probably the right way to do it. You don't want to jump in to the ocean before you wade in before you jump in, I guess. I don't know what the right analogy is. But that's a pattern that I'm seeing over and over again. And that's really interesting. It certainly informed a lot of our thoughts in Linkerd, where, I talked about multi-cluster. Our initial multi-cluster approach, the thing that we built in like 2019, was meant for these piecemeal situations. You've got this cluster over here, you got that cluster over there. You want to make them talk to each other without the developers having to know about it. Okay, here's the tools to do that. And that worked fine. But those semantics start to break down when you're like, instead of connecting two disparate clusters, you're like, I want to build 200 clusters and I want them all to be the same. And I want one layer of, kind of like service across all of them. Well, now those tools seem pretty clunky, and so you need a different set of tools. You've got a different set of demands. So that's part of this that's really exciting to me, is I feel like there's a lot of evolution that still has to happen on the Kubernetes space, because the way that people are tackling that is evolving in a pretty significant way.
William, what's next for you?
Eat lunch, maybe take a nap.
Good. No, that's good. You got to do that before you're going to do anything else. Yeah, those should not be forgotten.
No, we're at a super exciting time in Linkerd land. We just announced, Buoyant and Linkerd are kind of like these two entities, and I've historically tried to like kind of separate them. And I think what I've learned over the past year and a half is we've got to talk about them as the same story, because, this is exactly the advice I was getting in the very beginning of this conversation. What's my advice to, to companies, to CEOs of companies that are operating in the cloud native space? You got to be really explicit about that. You don't want to hide the fact there's a company and there's an open source project and there's this kind of deep relationship. But we just announced that we're profitable. Linkerd is getting new maintainers. Like, this project is suddenly, we've supercharged everything. So we've got a whole set of features that I'm super, super excited to ship next month with Linkerd 2.17. We're going to have egress control, which is the ability to turn off or to at least get visibility of traffic that's leaving your cluster. Super important for security reasons. We've got rate limiting finally in there. We've got this federated service stuff, which, is a direct response to what I was just talking about with people trying to build these new Kubernetes platforms. And then after that, there's a whole roadmap for Linkerd that is just full of the most exciting and interesting features. And I look forward to exploring those. That's what's next for me.
Fantastic. And if people want to get in touch with you, what's the best way to do that?
Just send an email to Bart at kubefm.com. And send, obviously you can email me, William, at buoyant.io. Just make sure you spell buoyant correctly, because the U and O go in a specific place. Look it up in the dictionary if you have to. I've also been using, thanks to Kelsey Hightower, using Blue Sky a lot. So you can find me on Blue Sky. I've kind of abandoned, Twitter, which as someone who was on Twitter for like 15 years and worked at Twitter, that's like kind of an emotional moment for me. But yeah, I'm giving Blue Sky a shot. So find me on Blue Sky, send me an email, or just come yell at me in Salt Lake City. I'll be there standing by the Linkerd booth. I look like this. I've probably done something to piss you off. So come on over.
All right, William. We're looking forward to talking to you soon. Take care. Have a good one.
Thanks, Mark.